Hello, and welcome to the fourth episode of this coding tutorial. In this episode, we are going to be talking about how to code simple drive controls. Before we get started, we're going to have to briefly talk about conditionals and condition statements. So conditionals are basically just the different ways you check the relationship between two values. So the 6 conditionals that exist are equal to, which is represented by 2 equal signs, not equal to, which is represented by an exclamation point and an equal sign, greater than, which is the greater than sign, less than, which is the less than sign, greater than or equal to, which is the greater than sign followed by an equal sign, and less than or equal to, which is the less than sign followed by an equal sign. So if we're looking at the code right here, I've just made 3 variables, a speed variable, a heading variable, and a starting variable. These are just for examples. We're going to walk through the first type of condition statement, which is an if. So the way you structure an if is you do the word if, and then in parentheses, you now tell it what it needs to check for. So for example, we're going to use the conditionals that we just learned, and let's have it check for if speed is equal to 10. And then afterwards we have to do curly brackets, and when speed is equal to 10, it'll run the code inside the curly brackets. So let's say, for example, if speed equals 10, we want the motor to stop. Great. So the next type of conditional is an else. And an else, you have to put it after an if. And basically, if speed is anything but 10, then the else will run. So if else, you don't need to put anything in parentheses, you just do the word else, and then do the curly brackets. For this one, let's say if the speed's not 10, then it speeds up. There we go. So right now, it's checking if the speed is 10. If it's not 10, it speeds up. Now the third type of conditional is called an else if. And it kind of combines the two. Because like else, it only runs if the if is false. But unlike an else, you can put a specific thing it has to check for. So you just do it right now, else if. I'm going to say if is starting equals true. And we want the robot to start moving. So now, if we looked at this code, what it would do is it would first, when we ran it, it would check if the speed is equal to 10. It is, so it would run this. But let's say the speed wasn't equal to 10. Let's say the speed was 11. Then the speed would check if it is equal to 10. It's not, moves on to the else if. It checks if is starting is equal to false. It is, so then it would start spinning it forwards. But let's say that this wasn't equal to false. Now, it checks if speed is 10. It's not. It checks if it's starting is false. It's not. So then, it sets the velocity to 100. Hopefully that all makes sense. Ifs, else ifs, and elses are very nice things to have. The other type of condition statement is a while statement. And basically, the way this one works is while whatever is in the parentheses is happening, then the code will run. Let's say that as long as the speed is less than 10, the robot goes backwards. Another type of while statement that's really good to know is while 1 and while true. Now both of these, you should notice, don't have any sort of conditional after them, because basically these are effectively both forever loops right here, because what we don't see is that this is secretly having like a while 1 is equal to 1 and while true is true, which is going to happen forever. So if you use either one of these, it just creates a forever loop, and the code inside here will run forever. So now that we understand what conditionals are and what condition statements are, we can now get on to the coding aspect. So the first thing is a thing that every drivetrain is going to need, and that is the ability to drive. Now in order for this to happen, you'll need however many motors you have split into 2 motor groups, one for the right side and the other for the left side. And you'll also need a controller. This tutorial is going to walk you how to make tank controls for your robot, which is where the right joystick on the controllers controls the right motors, left joystick controls left motors. Although, using this tutorial, you can probably figure out how to make all the other types of drive that you could possibly want. Alright, so the first thing we want to do is jump down to the user control and go into the while loop. We want to be able to drive the robot as long as we're in the user control period. Alright, so the first thing we want to do is create a variable that keeps track of the controller joystick positions so we can reference those. It doesn't matter too much what type of variable you make it, as long as it's a variable that can store a number, it'll get the job done. So let's just make this into an integer, name it our speed, and we want this to be equal to controller dot axis 2 dot position. I misspelled axis. Axis 2 position. Now you may be thinking, well, what is axis 2? If we go over and look at a controller, it has two axes on each joystick. Axis 2 and axis 3 are the vertical axes. So those are the ones we're going to be using. Axis 2 is on the right. This is the value we're going to set for the speed of the right motors. So that's why we're using axis 2. So then, once we have that, we want to do the exact same thing for the other side. So we can just copy that over. Do the same thing, except name it L speed. And instead of axis 2, we want to use axis 3. Now we have both of our variables. We just need to make the motors spin. So let's start with the right side, and we want the right side motors to spin. We're just going to say forwards because that puts it in the positive direction, comma, our speed, comma, percent. And now what this piece of code does is it's spinning the right motors at whatever variable we have here. And since the default position is in percent, we're also having this be in percent. Now, similar to before, we want to do the same thing for the left side. So we'll just have the left side spin at L speed this time and percent again. And there we go. If you download this code to your robot, then it should function. Now, what you can also do, thing to keep in mind, is that you can multiply this variable up here by whatever value you want to, and this effectively becomes like a sensitivity of sorts. So let's say your driver wants it to be like extra sensitive, you crank this number up. If your driver wants it to be less sensitive, you multiply it by a decimal. We're just going to keep it at 1 for now. So now let's move on to coding in button controls. Luckily, coding controls isn't that hard. If I go up here for demonstration purposes, I have a flywheel, which is in port 7. I have a claw, which is in port 8. So now that we have all that, we actually are going to go just above the user control function into this little space right here. I'm going to make it a bit bigger. And what we're going to do right here is we're going to make functions for each control that we want. So we're just going to start it off nice and simple. We're going to make one that moves the claw. So just like making any function, type in the word void, then we name the function. Let's just call this open claw. Then because we have no parameters, we're going to put the word void, do some curly brackets, and let's just have claw dot spin forward. And what this is going to do is, as long as we hold down the button, the claw motors are going to spin forwards. What happened when we let go of the button though? The claw is still going to spin forwards. This is because we don't have any function for when we're not holding the button. So let's change that. Let's go make a second function, call this one void stop claw. And this one is just quite simply going to stop the claw. Great. So we have one for opening the claw, we have one for stopping the claw. And while we're at it, just because, let's make one for closing the claw. So we have close claw, and then we want this one to spin it reverse. Great. So now we have our three functions set up. So we're going to go back to the while loop right here. Let's put our code above all the drivetrain code. So first we've got to pick a button for it. let's say to open up the claw, we're using button L1, and to close it, we're using button L2. So we go back here, it's got to do control dot button L1 dot pressed. Then in the parentheses right here, we put the name of the function. In this case, it's open claw. Now, normally, when calling a function, you want to put parentheses directly after it, but we don't want to do this here. Normally, if we wanted to put this like outside of the controller, then we would add in the parentheses afterwards, like that. Yeah. So when the button's pressed, it opens a claw. When the button is released, we want the claw to stop. And when L2 is pressed, we want the same thing to happen, except this time we want it to close the claw. And likewise, when we have it released, we want it to close the claw, or we want it to stop the claw. Great. So these 4 lines of code, each one references a function. So the power of having it in functions is that we can A, call each one multiple times from different sources if we need to, and you could have one of these run a couple different lines of code, and that's going to become more apparent for the second thing we're going to code, which is going to be flywheel controls. Now for the flywheel, we don't want our driver to have to hold down a button the whole time. That's kind of boring, so instead we're going to make it toggleable. So to do that, this time I'm only using one function, and we're just going to call it toggle fly. So the first thing we're going to want to do is we're going to want to make a variable that represents the current state of the flywheel. So we're just going to call like fly on. And by default, when you're first starting a code, it's not going to be on, so we're going to have it equal false. So when we call the function, we want it to first check if the flywheel is on. So to do that, we just do an if statement, have it reference the variable we made, and let's have it check first if it's false. So this means the flywheel is off, and if it is off, we want it to turn on. So flywheel dot spin forward. And we also want to change our variable to mirror that. So now the flywheel is spinning, the variable set to true. We're going to use an else statement here because if the flywheel isn't off, the only other thing it could be is on. So there's only 2 values, so an else statement will work just fine. We don't have to do any else ifs. So do an else statement, and if the flywheel is on, then we want it to stop spinning. And we want to change the variable to reflect that. Great. So now we just need to hook that up to a button. So just like before, we have control dot, let's say it's button A, if I can spell button correctly. There we go. If the button A is pressed, then it toggles the flywheel. And great. So now we have the code that toggles the flywheel whenever you hit the button A. If you hit L1, opens a claw, and then L2 closes the claw, and if you click in either of those, it stops. So, really quick, before we wrap up this episode, there's one other thing I want to mention, which is motor stopping types. So, if you notice, there is a function I can use called setStopping. Now, by default, this is set to break. Now, let's say we wanted to change that. So besides break, there are 2 other ones. One of them is called hold. And what hold does is hold will immediately stop the motor, just like break, but unlike break, once the motor stops, it still powers the motor, so the motor is harder to move. If you just by default, if a motor is stopped, then you can still kind of spin it with your hand, but if you have it on hold, you can't do that. You'll be met with some resistance by the motor. The other type of stopping is called coast. And like the name implies, the coast, what it does is it just lets the motor coast down until it stops. So the motor will stop increasing in speed and it'll just gradually decrease until it stops. There's no sudden stops, it's just gradual. Coasting is especially helpful for things that spin really fast, like flywheels, because if you have your motor try to stop a very fast spinning flywheel just as quick as it can, you're going to burn out the motor a bit quicker, cause it to overheat. That's a bit unfortunate. We would like to avoid that. So that's why coast is kind of good. And also, some people when driving like coast better. It's just kind of up to your driver. But yeah, you may also notice that I'm putting these above the while loop. That's because I don't want these to be running every 20 milliseconds. It only needs to do this once when it starts driver control. Because the more things you can have outside the while loop, a bit cleaner and nicer things are, you know? I mean, you could have them in here, they do the exact same thing, but they can be out, so let's just put them out. It also kind of helps stress out the brain a bit less. So, really quick, I'm going to go over how to code pneumatics. It's actually a lot easier than motors, so I'm just going to make a function for it really quick. Let's call the function flip. And what this function is going to do is it's going to reference our pneumatic, which in this case is flipper, and if you notice, it's just going to set it to true. This is because pneumatics have two different values. They can either be true, which is extended, or false, which is not extended. Sometimes these can be flipped around by the pneumatic wiring, but yeah. So to code pneumatic, all you gotta do is the pneumatic name dot set true to extend it or false to not extend it. Anyway, that is going to be it for this coding tutorial episode. I hope you enjoyed, and I hope you learned a bit too. I'll see you in the next one.